Today's session is called Confidence at Speed, Visual Studio 2017, and your CI pipeline. So in this session, we are going to cover and talk about the DevOps revolution that has absolutely roared through our industry. We're going to talk about how that affects us as developers, especially older developers like me. And finally, I'm going to show you guys some tools inside of Visual Studio that will help enable this DevOps journey you all are either going to take or already have taken. So before we begin, a quick introduction. My name is Abel Wang. I'm a senior cloud developer advocate at Microsoft. So that's a big, long, fancy title. What is it that I actually do? I basically do two things. I write piles of code all the time, and I talk to people. In a nutshell, that's what I do. I'm one of those freaks that love to code, and I code all the time. I eat, drink, live writing code. It makes me ridiculously happy. My running joke is, if I won the lottery today, I'm out. I'm quitting Microsoft so quickly. However, I would still be writing code, because that's how much I love it. All right, so I'm one of those people. What have I done? Some recent roles. I've been a process consultant. I'm a certified Scrum Master. I am an ALM Ranger. I write code with the VSTS team. My area of specialty is around DevOps, app dev, Azure, Visual Studio, blah, 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 right? So in a nutshell, I just write piles and piles of code. Some fun stuff about me. Back in the day, I used to be a rock star. Or, thank you. Unfortunately, I was kind of a failed rock star because I'm at Ignite talking about CI/CD pipelines and not at Wembley Stadium rocking a guitar, right? So yeah, that turned out the way it did. The other thing is I am a runner, and I'm currently training for the Great Wall Marathon in March, and I'm really excited about that. However, I don't want to be that guy in the middle, kind of like throwing up right there in the middle. That's probably going to be me. And finally, I am beloved by TSA agents all over the United States. Clearly, I fly around way too much, because it seems like it doesn't matter which airport that I go to now. I walk in there, and they're like, hey, Abel. I'm like, oh, man, I need to spend more time at home, right? All right. So let's talk a little bit about DevOps and how it's roared through our industry. Now, before I even start talking about DevOps, we probably should answer the question of what exactly is DevOps, right? You asked 10 different people, you're probably going to get 10 different responses. And it's not that they're wrong, but I want to give you Microsoft's definition of DevOps. And the whole reason is I just want to be able to have something we can frame this conversation we're about to have. So at Microsoft, DevOps for us is the union of people, process, and our products to enable continuous delivery of value to our end users. Now, notice I said that very, very carefully. To enable continuous delivery to our end users. And the reason why I said it so carefully is because every word has meaning in that one little sentence, right? I didn't say continuously deliver code, because what would happen if we just continuously deliver code? Absolutely nothing. We just have piles and piles of code, but it just sits there on a server, it doesn't do anything, right? Notice I didn't even say continuously deliver features, because we could be pumping out features over and over and over. But if it's not giving value to our end users, what's the point, right? So we want to be able to continuously deliver value to our end users. Now, why is this even important? Why do we care about continuously delivering value? In today's world, the speed of business is so ridiculously fast. We absolutely need to continuously deliver value, or we're going to be left behind. The most extreme example that I can think of is in the mobile app world. Let's think about how we behave with our mobile apps, or at least I can say how I behave. If my app doesn't get updated for a while, my first thought is, you know what, devs, they've abandoned this. I'm going to find an app that's out innovating them, download that, and it's going to be a lot cooler. Right? What happens if I download an app, start using it, and it's crashing all the time? That's game over, man. I'm uninstalling that so fast, and I'm installing something new that is not buggy, that is innovating faster, right? That's kind of how we behave. Now, I know in the mobile world that's kind of extreme, but we've now come to expect all of our software to be like that, to be innovating all the time. And this is not an easy thing to do, to go innovate all the time. I think the best example is look at what happened with Microsoft. Back in my day, remember, I'm old as dirt. Back in my day, we used to deliver software once every 3 or 4 years. So what was our workflow? We'd spend a year gathering requirements. We spend another year writing all the code. Then we spend another year burning down a mountain of bugs. And I mean a mountain. And we'd never really burn through it, because by then it's just way too late, right? You have way too much debt. However, hopefully it gets good enough. We're ready to ship it. Now we need to figure out how are we going to ship it? What does that even mean? Does that mean we burn it onto a CD, shrink wrap it, and then send it to Best Buy or Office Depot? I don't even know if Office Depot is around anymore. But that's what we used to do. Plenty of time to kind of figure out how to do all of these things. But today's world, you can't move at that glacial pace anymore. You have to move at the speed of business. So at Visual Studio Team Services, the team that I work with, we ship every 3 weeks, like clockwork, every 3 weeks. New features get created and sent out into the cloud. Our customers see new features every 3 weeks, like clockwork. What we don't tell most people, and I'm going to tell you guys today, is that every single day, 2 times a day, we push out bug fixes, hot fixes, 2 times a day. So what does that mean? Depending on the branch of code that we're coming from, every developer check-in potentially could reach all the way out into production on that very same day. Now, let that sink in for a moment, because that blew my mind when I realized that that's what we were doing. That is moving at ridiculous speeds, right? How can you do something like that? It's not easy to do something like that. So what you need to have a process that will let you iterate fast enough, yet still deliver code of high enough quality, right? So what does that actually mean? That means I need to be able to have a system where every time I check in my code, I need to kick off a build. And this build will grab the latest code from source control. We'll compile everything. We'll run all of my unit tests. And at Microsoft, every time I check in code, do you know how many unit tests I have to pass? Last time I counted, it was 67,000 unit tests. Every developer check-in has to pass over 67,000 unit tests before it can flow into production. Why so many? Because how else can you maintain quality, right? You have to have that mindset of always thinking, how can we iterate fast enough but still maintain quality? So I need this build system to do all that for me. Check in code, kicks off the build, runs all my unit tests, and if everything looks good, I need it to trigger a release pipeline. And my release pipeline needs to go to the build, download my build artifacts, and start deploying my code through the pipeline. Dev, QA, UAT, so on and so forth, right? Eventually all the way out into production, whatever production means. And I need this system to be fully automated. Why do I need it to be automated? I need the system to be repeatable and consistent every single time. If I'm building and deploying out to production multiple times every single day, I can't have a human being X-copying bits from here to there, remembering to change the web config. Like, back in the day, when I was really young, I may or may not have pushed code into dev, forgot to change my web config connection string, and it still pointed to my production databases. That was painful, right? And unfortunately, that's the type of stuff that happens if a human being is moving bits, especially if they're moving bits over and over and over again. So if I have an automated system, a CI/CD system, that can do this for me automatically, consistently, repeatably, every single time the same way, that alleviates this type of problem. So that's the type of system that I need. There's another thing that we noticed as well, is that the way that we checked our code in and handled our code in our branches, that needed to change as well. It didn't scale in this hyper agile world that we lived in when we were iterating so quickly, right? So, case in point. Back in the day, how did we branch our code? We had a main branch. We had a long-living QA branch. We had a long-living dev branch. And as developers, we'd check into code to dev, we'd play around with it, found bugs, made more changes. Eventually, we said, you know what? We think the quality is good enough. Let's go ahead and push our changes into QA. That was supposed to be an arrow. And once code hit QA, our QA teams would test it. They might find bugs. We'd go back and fix it, push code down, and eventually they'd say code is good enough. Let's merge to master, or I'm sorry, main, and then the cycle would rinse and repeat. How many of you guys have seen a branching strategy similar to something like that? Right? We all have. So the problem is, in a hyper-agile world that we live in, where we're delivering code every 3 weeks, where every one of, and then depending on the branch that I'm coming from, every one of my check-in potentially could flow all the way out into production. This type of branching strategy just started breaking apart for a lot of reasons. The main one was when we started working, let's just say I'm on a team of 5. All 5 of us needed to immediately start working on different user stories. We needed to be isolated from each other. Because if we weren't, our code would just start walking on top of each other. We couldn't build. It just turned into a nightmare, right? So we needed somehow to be able to isolate our branches from each other as we were working on our different user stories. The other thing is, once we started merging code, and we were merging code as fast as we possibly can, 2 things happened. Our history of our main branch turned into a colossal mess, to the point where you could look at it, but nobody could really understand it, right? It was just pure gibberish. There was no reason for us to even keep history anymore because it made no sense. It was so messy and messed up. So we needed a system that could let us, instead of using these long-lasting feature branches, we wanted to have really short-lived branches, isolate our code for a specific user story, and then immediately merge things back in. So what we wanted a system, a source control system that would let us do something like this. So if this is my master branch, instead of having a whole bunch of long-living branches, I want to have lots of short-living branches. So if I'm going to be working on a user story, let's create a user story branch, and we'll call this user story 1. I make my changes in here, and when I'm done, merge it back immediately. And if I pick up another task, user story 2, make my changes in here, merge that back, hooray for that, right? Well, remember I said we always have to think about quality, right? So I don't just want to be able to spin up a branch really quickly, make my changes in there and merge it back into master. I want to make sure I have a code review. And this is absolutely vital. And at Microsoft, every developer check-in absolutely has to go through a pull request. We don't let any code through without someone else on the team actually looking at it, putting eyeballs on it, putting in comments, and either accepting it, rejecting it, or adding more changes. So what we want to happen is, great, we can spin up a branch for, let's call this user story 3. I write the code. I think I'm done. I want to issue something like a pull request. Well, not even something. I issue a pull request, a code review. And I'm going to assign one member of my team. They can look at it and be like, oh, I don't think that's right because of X, Y, Z. I'm like, oh, yeah, you're right. So I'll go ahead and make some more changes, continue on the pull request, and at some point in time, quality looks good enough, we merge it back into master. Right? And when we merge it back into the master, let's go ahead and kick off these builds. Let's run all 60-some thousand of our unit tests. If everything looks good, let's start propagating it through our different environments. Right? So that's the type of workflow that we needed to have to be successful in this hyper-agile scale that we were working at. And if there were lots of people on my team, it would look something like this. I have user story 1 that I'm working on. Maybe another team member is working on user story 2, maybe user story 3. When I get done, I merge it into my master branch, and hooray for that, I win, because I'm the first one that did it, right? Because all subsequent people, before they can merge into master, they need to make sure they merge the code from master back into their branch so they pick up my changes, and there may or may not be code conflicts. That's just the way it is. I mean, you're taking code and merging it into code from the past, potentially there's going to be code conflicts. So we needed a system, a source control system, that would let us detect these conflicts and help merge these changes in a really nice, clean way. And in a centralized version control system, it worked, but it was kind of clumsy sometimes, right? And especially if we didn't have a way of rewriting the history. If we have a ton of these branches going on, it just kind of broke apart and turned into a colossal mess. So that's kind of why we went from a centralized version control system to a system like Git, a distributed version control system, because that actually worked really well. We're able to spin up all these little branches super fast, super quickly, use it, merge it down into master, immediately delete the branch when we're done, right? So Git actually worked extremely well, and we ended up moving over to Git. Lots of power inside of Git. However, Git's kind of complicated to use, especially for old people like me. How many people in here, I'm going to put you all on the spot, how many people in here, they're over the age of 40? I'm just going to raise my hand. All right, how many of you people over the age of 40 absolutely hate Git? You can raise your hand. We all hated Git. I despised it when I first had to play with it. I was like, what is this madness? Why am I even doing this? This is ridiculous. Why is it so complicated? But we quickly realized the power of it the more that I started using it, right? But the fact that I had to jump into the command line and do everything, well, that's not true. I'm actually a huge command line junkie, so I kind of took to it, and I loved jumping into the command line. A lot of my coworkers, like Donovan, he hates the command line, right? He loves himself some Visual Studio. He likes being in there. It gives him that warm, fuzzy feeling, right-clicking on everything. But guess what? We have tools inside of Visual Studio where you can actually use Git now, where you don't have to jump into the command line. So anyway, those are the two big things that I really wanted to talk about today. Let me jump back into my slide deck. So today, yes?
Can you contrast the every 3 weeks with the daily release? How does your diagram that you're talking about differ between those two?
So the question was, can I contrast the release cycle of every 3 weeks versus our hot fixes that actually go out every single day? The branching scheme actually looks different. What we're doing in VSTS is a lot more complicated than and a lot bigger than a lot of other projects. So instead of just one master, we actually have a hotfix branch as well. Right? So it does complicate the picture a little bit, but it's something that we need because we need to be able to pump out hotfixes all the time. And in fact, we may or may not have multiple hotfix branches, but that's a whole different ball of wax. So today, what I wanted really to do, though, is I wanted to look at like the most simplistic model, just to kind of give everybody a basic feel of, okay, this is how we can do things. So what I'm about to do is I'm about to jump into my demo. And in my demo, we're going to look at how can we create a project that uses Git. How can we have our code reviews or our pull requests? At some point in time, if we're using Git and we have all these short-lived branches, we're going to have merge conflicts, right? So how do we fix these merge conflicts? And how do I create my CI and CD? All within Visual Studio and Visual Studio Team Services. Because once again, as an old school dev that's over 40, I'm not really a CI/CD person. I don't really sit there and create builds and releases all the time. That's someone else's job, right? I don't care about that. And Git, oh my goodness, whatever. It makes no sense to me as well. But in this new DevOps world, there's that whole shift left mentality, right? Where things that used to go to other teams has shifted left, and it's now part of the inner development cycle. Whereas developers, we need to pay attention to this. So lucky for us, or me, old people like me, there are tools inside of Visual Studio that help enable all of this. So let's go ahead and jump in and take a look. So the first thing we need to do is let's go ahead and create a project that actually using Git. So what I'm going to do is I'm going to start off my project by using Visual Studio Team Services. And we're going to create a brand new project. So let's call this project Ignite 2017. We're going to use the Git version control. We're going to use the agile. We'll click Create. And so now it's going to go ahead and spin and create me a brand new team project in VSTS. And it's going to create me an empty Git repository. And it's going to have no work items in there for me to track at this moment, but we'll fill that up pretty soon. So now that we've created a VSTS team project, how do I get that repo cloned onto my own machine, right? Well, I know what I would usually do is jump into the command line, issue some esoteric Git commands, git clone, pass in the URL, bam, and everything kind of links together. But we can make it a little bit easier than that, too. There's nothing wrong with doing that. Actually, that's what I always do. But we do simplify things. So we can clone this inside of Visual Studio just by clicking on the clone button. So if we clone this, it's going to go ahead and launch Visual Studio for me. And after it launches Visual Studio, it needs to connect up to my account. And let me go to my correct account. And I need to enter in my password. And of course, it's going to ask for my two-factor authentication. So bear with me as I go through this exciting process. Ooh, I need my code. And my code is, how about 356740? And we'll verify this, and we'll go ahead and connect. And hooray for this. So now it's going to reach out. My Visual Studio is going to reach out to VSTS. It's going to go ahead and make a connection. And when it finally does make a connection, it's going to ask me, where on your hard drive do you want me to clone your repository? Right? So I'm pretty sure nobody can actually read that. So let me zoom in there so you guys can actually see it. That was not where I wanted to go. My scaling is all messed up. All right, then I won't worry about it. But basically, we can go in and choose where we want to create our repository. So where I actually want to leave my repository is here under Ignite. Let me click OK. And we'll go ahead and clone it. So now it's going to connect up to VSTS. It's going to grab whatever code is in there, which is nothing. And then it's going to clone that repository on my hard drive in my laptop. And where it's going to clone it into is actually going to be right here. Right. So when it finally pulls everything down, there's not going to be any code, but it will pull down a .git folder. And that folder will have all my Git information in there. And it will pull down as well a .vs folder. But it's relatively empty. Right. So great, it just pulled everything down. If we go into Visual Studio, we can actually see that, yes, we pulled the code down, but there's no code, right? It's basically an empty folder. So I've already prepared for you guys a beautiful, I'm kidding, it's not, it's just a simple template, solution, VS solution, that has an ASP.NET web project already in it. And it's just the template that comes when you say File New Project. So I'm going to go ahead and copy that over. So let's jump in here. Let me go to BRK for breakout. And let me go ahead and copy all of this nonsense, copy that into my Ignite folder. And once it gets done copying, you'll actually see everything show up in my Solution Explorer. Right? So then slowly these files propagate in here. So what we want to do now is open our solution. So let's double-click the solution. And now we're into the normal Visual Studio goodness that we're all used to, right? Hooray for this. We can compile it with an F6. Let's go ahead and run it so you guys can actually see this is a working web application. It's going to launch IIS on my desktop. I'm going to open up the browser. It's going to point to it. And when it finally opens up, because it has to compile everything and all that stuff, it's just the standard web app that comes when you say File New Project, right? OK, not a big deal. But now, what do I want to do? I want to take that code, and I want to upload it into VSTS using Git. How do I do that? One way, of course, is to jump into the command line. And we can do a git status, and we can see all the files. We can do a git add star by adding all the code in and do a commit and git push. We can do all that, right? Or we can do everything in Visual Studio itself with the Git tools. So let's jump into Visual Studio to see what that actually looks like. So let me jump out of my debugger. And what I'm going to do is I'm going to jump into my Team Explorer. I'm going to click on my changes. And from here, I'll be able to see every single file that I changed. Right? And so for all you people that love you some Visual Studio and love you some right-clicking, you can still right-click, you get your context menu, you can add files, remove files, exclude files by a certain extension, et cetera, right? But those people that do the right-click everywhere, guess what? It's right here. It's ready for you to do that. All right, so let's go ahead and add our code in. We need a comment, so we'll call this initial check-in. And we can commit and push our changes to VSTS. So in the world of Git, what the workflow usually is, I commit my changes, and it commits it into my local repository. So I have my source code repository, I have a copy of it on my local hard drive on my laptop. Right? So I would commit it in there. And after it's committed, I would push those changes up to VSTS, right, which is my central repository that I'm storing all of my code. Now, that can be 2 commands from the command line, or we can do it in 2 commands through Visual Studio, or we've made it simpler for you as well, where you can just say, you know what, commit everything, and let's go ahead and push our changes all the way into VSTS. So now it's going to package everything, it's going to compress all the files, it's going to send it up to VSTS, and if I jump into VSTS, and let's go into the code, you'll see that I've now checked in all of my files. Let's jump into the files, and hooray for that. Project checked in. Success. All right, so we've managed to create a project using Git from Visual Studio, check in our project into this Git repo, and send all that back up into Visual Studio Team Services. Yay, we just won one small battle. All right, the next thing that we want to do is, great, we need to make some changes, right? So remember I said the workflow is usually, well, if I'm going to be working on a user story, as a developer, I should create a branch for myself, make the changes in there, and issue a pull request, have someone review my code, and if everything looks good, let's merge it back into master. So let's see how that looks inside of Visual Studio. So the first thing I'm going to do is I'm going to jump into my work section, and I'm going to create a unit of work for myself to do. So let's go ahead and create a new user story, and we're going to call this, I don't know, demo user story. Good enough. We can even jump into our Kanban board, and we can say that this is now active by dragging the work item across the Kanban board, calling it active, and now this work is assigned to me. So I can also go into my Visual Studio. What I want to do now, remember I said every time I do a unit of work, I want to create a branch for myself to work in. So once again, I can create branches in a lot of different ways, but the one that I wanted to show you right now is, let's go ahead and create it through Visual Studio. So here, let's jump in here, we'll look at our branches, and we'll go ahead and right-click on our master branch. We say we create a new local branch, and we'll call this our Demo1 branch. And just like that, I've created a branch for myself to work in. Nothing special. Now that we're in here, let's go ahead and make some changes. So let me jump into the controller, and I'll open the home controller. And I'll add a line of change. Demo1 code. And let's go ahead and check that code in. So I need to go into my changes, and it'll detect the file that has changed. I only changed one file. If I change a whole bunch of files, it would detect all those changes as well. And let's leave a comment. Demo1 code. Yeah, I know, these are horrible comments. And I can go ahead and commit and push my changes, or another thing that I can do is I can link the work item that I'm actually working on to this particular check-in as well. So let's go ahead and do that. I can search for the work item ID number by jumping into the user story. Let's open it up, and this one is 2742, okay? So we'll just call this 2742. The other way is you can actually search for it and then drag and drop it in as well. So we'll go ahead and add it. Let's go ahead and commit, and we'll push our changes back up to VSTS. But what are we pushing? We're not pushing into the master branch, we're pushing this Demo1 branch, right? So if we go back into VSTS, we should see a Demo1 branch. So we jump into VSTS, let's jump into the code section. I can look at all the branches that I have master, and there's the Demo1 branch that I just pushed up in there. Right. All right, so for me to get my code into the master branch, I now need to go through a pull request. So the way to do that, actually there are a lot of different ways to do that. The first thing I'm going to do is I'm going to show you how to do it through Visual Studio, and then I'm going to show you the way that I really like to do it, because I just feel like it's a more seamless workflow, but you guys can decide for yourself. So through Visual Studio, to create a pull request, let's go to our Team Explorer again. Let's jump into our branches where we can see all the different branches. I'll go ahead and right-click on my demo1 branch, and I'm going to say, let's create a pull request. And it will launch me in the browser in VSTS, where I can start my pull request workflow. So it's already created for me a title, a description, and that's based on my comments that when I checked in. And it even automatically connected to me the work item that I was working on, right? The 2742 demo users. So from here, I can start adding people to review my code. So I can say my buddy Donovan can be one of my code reviewers. Or I can even have VSTS automatically assign people based on the folder that my work is coming from, right? So it's very flexible, and I'll show you guys how to set that up in a minute. But in the meantime, what we're going to do is we're just going to say anybody on my team can be part of my pull request. So let's go ahead and create it. And once we create it, what we see is a timeline of my pull request. So at this moment, nothing has happened, so it's just my initial check-in. But if I click on Files, I'll be able to see every single file that I touched and the changes that I made. Of course, I only made changes to one file, so that's all that shows up, so it's kind of boring. But if I touched 20 files, they would all be here, and I can do diffs and see exactly what's happening. So now I can actually start leaving comments for my pull request. So let's leave a comment. Your changes are brilliant. And we'll go ahead and commit that. And I can reply. I can reply with Markdown even, or I can even reply back with a GIF. So let's do that, because this is my favorite GIF ever. And hooray for that. Now, I wish all of my pull requests went like this. Unfortunately, most of them do not. So what happens if I get a comment that says, I need you to change XYZ? Well, that's actually not a problem. I just go in, change whatever I needed to, and re-upload it to this branch, and continue on with my pull request until it finally passes. Man, that little dude's just dancing. All right. So we'll go ahead and resolve this one. And we'll go in and leave another comment. Capitalize demo, please. And that's fair enough. Maybe I need to capitalize demo. So then I would just go into my code. We'll go ahead and make that change. Like that. Now let's go back to our changes. We'll leave a comment. Uh-oh. I think I just froze Visual Studio. So this morning, I don't know why I did this, but I updated, and I really shouldn't have, because now my computer freezes all the time. So let me see if I can get it unfrozen. Otherwise, I'm going to have to do this. Fantastic. All right, end task. Let's try this again. All right, so this demo may get pretty painful if I have to kill Visual Studio like that all the time, but that'll teach me to do an update right before a demo. And of course, I have to log back in again. And two-factor authentication time. Good thing we're super secure. 058181, verify, let me in, hooray for that. Connect up to Team Explorer, do a song and dance while it doesn't connect, and when it finally does, I have to remember what I was doing earlier. So I think what we needed to do was actually commit our changes and push them back up into VSTS, right? All right. So let's go ahead and look at our changes. We are in the demo1 branch. We can see our changes. Let's leave a comment, fix problem for demo. We'll commit and push our changes back up to VSTS. So now we can go back into VSTS, and what you'll notice, let's go ahead and refresh this. We have a brand new update because I just pushed code in. If I go ahead and refresh this, It's going to come back, and you'll see my changes actually in there. So now I can say, yeah, man, it's fixed. Let's reply and resolve this, and hooray for that. We're done, right? Now, if we go to our timeline, the overview, you'll actually see things that made sense. This is a timeline of everything that I did in my pull request. So this workflow, this is a beautiful freaking workflow. I love this. We use this all the time. This actually makes the whole pull request or code review process relatively painless. Well, as painless as code reviews can actually go. So at some point in time, we're either going to approve this or reject this. Right? We can keep on going until we finally approve or reject it. For this demo, we'll just go ahead and approve it, and let's go ahead and complete it. Now, once we go and complete this, VSTS will give us some options. It will let us automatically take that linked work item that we were working on, and it can automatically close it out for us. Right? That's really nice, because a lot of times I check my code in, I forget to close out my work item. Right? So it can automatically do that for us. It can also go in to VSTS, and this developer branch that I was working in, it can go ahead and delete it, because I'm done with it now. Right? Remember, these branches are super short-living. So now, that's another thing that I used to always forget. And then next thing you know, our repo in VSTS has like 1 million branches, and now you can't find anything. So now VSTS can go ahead and close that for you automatically. And finally, what it can do is it can actually take all that chatter that's going on in my dev branch right now, all that check-ins and fixing everything from my pull request, and it will squash all those changes down so that by the time it hits the master branch, it's one clean commit, one clean merge. So my master branch remains really pretty and pristine. So I'll show you what I mean. So let's go, and I don't want to close out my work item right now because I'm going to use it for another demo. But we'll go ahead and complete it. The code merges, it hits master. Hooray for that, we're done. Let's go ahead and jump into our files. We'll look at our commits, and we can actually see the history. So all of the chatter that was going on in my dev branch, we squashed it all, so by the time it hits master, it's just the initial check-in, and then our merge pull request, where I added in my demo 1 code. So that right there is your typical workflow for a pull request, right? How I actually get code from my desktop into a Git repository and using a pull request. All right, any questions so far? Yes, I think all of the sessions are videoed. Okay. Is this useful? You want? Perfect. All right. So this is great, right? But it's a highly simplistic version, because usually there's about 5 or 6 of us all doing user stories at the same time, all doing pull requests at the same time. At some point, we're going to have a code conflict, and we have to merge, right? So let's take a look and see what that actually looks like. So let's go back into VSTS. And from here, let's change back. Well, actually, let's open up our controller again. And let's switch back to the master branch. So when I switch back to the master branch, you notice the code reverted back to like before I even did anything. Why did it do that? Because the change was merged into the master branch way up in VSTS, right? I haven't pulled those changes down to my desktop yet. So I need to pull those changes down. So how do you do that? Personally, I would jump into the command line and just do a git pull. However, you can do it through the code as well by going into Team Explorer, by going into the sync, and let's go ahead and pull our changes down. So now it's going to pull those changes down. Demo 1 code shows up. We're now perfectly in sync between what's on our repository on my laptop and the repository in VSTS. Right? Okay. So now what we're going to do is we're going to simulate a merge conflict. So this is always fun to do. All right, what could possibly go wrong this time? Let me jump into my branches. And from here, before we begin, let me do this. So remember, one of the things that we did was I had the checkbox checked so that if the merge of my pull request was successful, delete that branch. It deletes the dev branch from VSTS, but it doesn't delete it from my local repo, because that's my local repo, right? So what I just did was from the command line, I said, fetch me all of the changes, including the deletes. So now if I go back into my branches and open up my remote, and my remote is VSTS, you'll see that it only has a master branch. I still have the demo 1 branch because that's local, but I really don't need it anymore, so let's go ahead and delete it. What I like about this is usually I keep my own branches around for a little bit until it actually ships out the door. And once it does, I really don't need it anymore. It's just cluttering up my desk, so I just delete it. All right, so we're going to simulate a conflict. So let's go ahead and create a branch, and we'll call this demo 2. And let's go ahead and create another branch, and we'll call this demo 3. And then let's go into the demo 2 branch. We'll add some demo 2 code. And let's push this up to VSTS. Leave a comment. We'll do a commit and push all the way up to VSTS. And let's go back to our demo 3 branch. Let's add some changes in here. Demo 3 code. Let me save that. Let me go ahead and go into my changes. Leave a comment. Uh-oh. Frozen machine. All right. I really should just keep my task manager up. There we go. All right, so let me go back into my changes. I'm in my demo 3 branch. Let me add my change, demo 3. We'll commit, push those changes all the way back into VSTS. So now when I go into VSTS, I should see my demo 2 and my demo 3 branches because I pushed those changes back to VSTS now. All right, so I want to do some pull requests. So let's go ahead and do a pull request. So let me go back to my branches. And let's do a pull request for my demo 2 branch first. So let me right-click that, and I'm going to say create a pull request. So we create the pull request. Oh, I did it for demo 3. That's OK. So we created a pull request for demo 3. We can go ahead and create. Hooray for that. It looks good. We'll go ahead and complete it and approve it. And it merges. If we wanted to, we can now go to our demo 2 branch. We can go ahead and try to create a pull request from here. And it is on the demo 2 branch. I'm not sure why. Well, let's take a look and see. All right, we can do it like this. So there's a lot of different places that you can actually create your pull request. You can do it from Visual Studio, or you can do it from VSTS as well. Now, if I go ahead and try to create a pull request, it's going to get mad at me and tell me, you know what, you can't because you have a code conflict. So I can continue on with my pull request. I can actually do reviews, but it will never let me merge back into master until I resolve all of my conflicts. Right? So let's go ahead and resolve our conflicts. So let me go into my Team Explorer. Let me jump to my sync. Let's go ahead and pull all the changes down. Actually, let me first go into my master branch. And let's pull all of our changes down. All right, so now what we want to do is we want to merge our changes. So let's go to branches. So we're on the demo 2 branch. And we're going to merge from the master branch into our demo 2 branch. So once I try to merge, of course I'm not going to be able to, because it's going to tell me I have a conflict. So let's jump in and look at our conflict. It will actually list out every single file where my conflicts are. I only have one file with a conflict, but if I had multiple, it would show them. If I actually click on it, it will give me the option of merging it in a merge tool. I can compare the files using a compare tool, right, to see exactly what the differences are. For convenience, I can automatically take source or keep the target, but for this demo, let's go ahead and use our merge tool. And this is a third-party merge tool that I'm going to use, and I'm going to want to add B and also C. Let's go ahead and save this, and we'll close out of here. And yes, this is fine. Commit our merges. Merge code. Commit and stage. And hooray for that. So now if we refresh, oh, I still need to push my commit and push my changes in. And let's go into our sync. Push all of our changes in. Let me just do a quick check. Come back in here, and everything's clean now, right? So it figures out that, you know what, now I can merge my changes back into master. So if I go ahead and actually complete this, we'll merge all of our changes back into master. So now, when we look at master, that's our history. That's what it looks like now, right? So that's the type of workflow that we would usually do if you actually hit merges and how you can actually fix merges. So merges in Git, they seem kind of scary at first, but really it's not that big of a deal, especially if you have a nice merge tool that can access like all 3 of your repos at the same time, right? You can do compares and figure out what you need to do. All right, so that workflow is just a little bit clumsy for me. Right. So yes, did you have a question?
What was that third-party merge tool you were using?
Come up to me afterwards, and I'll give you everything that I have. All right. So, and there's actually a whole bunch of third-party merge tools that are fantastic. That's just one that I downloaded because I liked it. All right. So this is the workflow that I like to do because that just seems a little clumsy to me. What I usually do is this. I go into my work. I find what work I need to do, which is demo user story, and I create my branch directly from the work item itself. So let's call this my demo branch XYZ, and I create the branch. Just like that, it creates the branch for me. I come back into Visual Studio, I pull down my changes, and let's go into the master branch. Oh, great, I just froze everything. All right, so while this is rebooting, goodness gracious. And I will launch Visual Studio from here. So while it's launching Visual Studio and doing all that nonsense, I'll actually just pull my changes down here. Oh, well, actually, it's a little bit faster than I thought. Demo branch XYZ. right? So everything you do through the tool, you can do through the command line as well. And like I said, I am a command line junkie. That's where I live. But you can do it through the tool as well. So now we're in the demo branch XYZ. We have pulled all the changes down. I can make whatever changes that I want. And let's see. Let me open up my controller code and add some changes here. And let's go back into our Team Explorer to check in our changes. Added XYZ code. Let's go ahead and commit. And this time I didn't commit and push, so I do need to push my code. So let's go to our sync. And you can see I have one change that I still haven't pushed to VSTS, or the central repo. So let's go ahead and push those changes. And now VSTS should have my changes. So if I jump into VSTS and I do a refresh, VSTS is smart enough to know that, you know what, I just pushed new changes for this particular branch. Do you want to create a pull request? Which I do. So I can click on create a pull request, and then bam, it just drops me directly into that workflow. So this is the workflow that I usually use personally. I just think it's a little bit better than trying to do everything through Visual Studio itself. So I actually use the browser, the command line, and Visual Studio as well, all three. Right. So of course, we can go ahead and create this. Let's go ahead and finish the changes. And hooray for that. We merged our changes now. So there you go. Git, it's a little scary for people that haven't used it before, but we do have tools in Visual Studio so that you don't have to drop to the command line unless you really want to. All right. One of the things that I was going to show as well, I don't know if I have time. I think I have time if I can do this quickly. I was going to talk about the differences between merging your code and rebasing. Do you guys know the difference between merges and rebase? All right, I'm seeing people shaking their heads and some people nodding their heads. So I'll just talk about it really quickly. Rebasing and merge accomplish the same thing, but they do it in different ways. What happens is I have two branches of code. Let's say I have branch A and branch B. I can get the changes in branch A into my changes into branch B. And the way that I can do that, which is a merge, or I can do it with a rebase. And the difference really is like this. With the merge, with the merge, it looks something like this. I have change 1, change 2. Here's my extra branch. Maybe I have change 3, change 4. Somebody came in and made changes to my master branch. And if I want to do a merge, it actually sticks that code at the end. Right. So the problem with that, actually it's not a problem, but what ends up happening is your code looks branching. If you look at the history, it will look something like that. Right. Another way that you can do it is by rebasing. So if this is my code, 1, 2, let's see, 3, 4, 5, 6. If I rebase, what ends up happening is I take my changes 5 and 6, I put them in front, and then I replay changes 3 and 4. What's nice about this is now our history, instead of having all these weird branches and merge, it's super clean. It's just basically one straight line. I know it's jagged, but it turns into one straight line, right? 1, 2, 5, 6, 3, 4. And the other benefit of that is if you have lots of different branches from lots of different team members, now they can merge your stuff. It's a lot cleaner with less conflicts. So this is a super powerful thing. It can also be very dangerous, but you do need to be careful about which direction that you merge from. But the nice thing is, inside of Visual Studio, you have the ability to do that really, really easily. So if you have multiple branches, let's see if I have multiple branches. I do. I can easily say demo 3, right-click it. I can say, you know what, let's go ahead and rebase onto, and I can choose another branch. I click rebase, and then it just magically happens. All right? Okay. So rebasing It's kind of scary through the command line, through Visual Studio and the Visual Studio tooling. It's not that big of a deal. All right, any questions so far? All right, so being able to use Git from Visual Studio is really powerful, especially for those developers that don't like the command line, that love being inside of Visual Studio all the time. That's great. We can now create a project using Git. We can add our code into Git. We can check our code in. We can do code reviews or pull requests. We can merge conflicts. We can handle that as well. We can rebase. Now all that's left is CI/CD, right? And as an old school dev, I'm kind of thinking, I don't really want to worry about CI/CD. That's someone else's problem, right? Except, like I said earlier, we've shifted left a lot, and it is our problem. But Visual Studio is here to help you and make it really, really easy. And let me show you that. This is actually probably one of my favorite demos to give. All right, so the first thing we need to do is we need to download the right extension. And the extension that we want to use is going to be, let's go ahead and go to Search Online. And we want to search for the continuous integration, continuous deployment. Wow. All right. Let's try this one more time. I wonder if I'm going to have to go through the whole logging in process again. That was ridiculously fun. Here we go. And it connected. Hey, I don't have to log in. Fantastic. All right, so let's go ahead and go to Tools. We'll go to Extensions and Updates. We're going to go to Online. Let's go ahead and search for Continuous. And it's the very first one that we want to pull back. Continuous Delivery Tools for Visual Studio. So go ahead and install it. I've already have it pre-installed. And once you have it pre-installed, you can actually come up to your solution now, right-click on your solution, and you get a new context menu called Configure Continuous Delivery. Now, this is a very important thing. I want you guys to listen carefully. This is not right-click deploy, all right? Right-click deploy, what that does is it takes the code from my laptop and deploys it into production. Friends don't let friends right-click and deploy. Right? That's my buddy Damien, he's the one that coined that phrase, and I freaking love it. Friends don't let friends right-click and deploy. You can do it for your dev environment, that's fine. In an enterprise setting, never right-click deploy. Why? Because that's just taking bits from your laptop and shoving it up into production. This is so dangerous. So many things could go wrong. What this does, it actually builds out a CI/CD pipeline that goes all the way out into production. So let's go ahead and do that. All right, so we'll go ahead and grab the Configure Continuous Delivery. It's going to go ahead and connect up to both my Azure account and also my VSTS. And now it's going to go ahead and create my pipeline for me. So the first thing it's actually going to do is that it's going to go into Azure, and it's going to create a resource group for me, and it's going to create an app service for me, a web app for me. And it's going to be an empty web app, but at least it will be there. And when that's done, it will go into VSTS and create my CI/CD pipeline. So let's go ahead and jump into my Azure portal, and let's refresh this, and we'll see that it actually created my Ignite resource group. I can jump in here and see that it does have a web app. Let's jump into the web app, and if we browse to it, we'll see that it's empty and hasn't been configured just yet. So here it is. Let's go ahead and browse to it, and it should come up with the empty, standard empty Azure App Service account. Hasn't been created just yet. Now, if I jump into VSTS, we'll see that it has created a build for us as well. I'm assuming it's done. We'll see if it's actually done or not. And the build has actually been triggered. And this build, remember, we didn't have to do anything. It just took care of itself for us. This build is a real build. It's getting the code from source control, it's compiling everything, running all of my unit tests, and when it's done, it packages everything up, ready to be deployed. But just because we built this pipeline out for you, you still have complete control over it if you wanted to configure it. So if we go into Edit, you can actually see what the build is doing. Now, the build in VSTS This is a build. I freaking love this build because it's so flexible. It can do anything that you want. It's basically a task runner. It does one task after another after another. So in this case, I'm restoring my packages from NuGet, building my Visual Studio solution, running my unit test, and publishing everything back up to VSTS. Pretty simple, right? For me to configure it, I can just add or remove tasks. And out of the box, there are hundreds upon hundreds of tasks for all sorts of different languages and platform. This build system is not just for the Microsoft stack. It's not just for .NET. Using this build system, we can build for any language, targeting any platform. You want to build Java on Linux? Not a problem. You want to build iOS on Mac? Not a problem. You want to build Python on Windows? Sure, why not? You want to build .NET Core in a Linux container? Absolutely you can, right? Any language targeting any platform. Just find the task that you need and start using it. And if you can't find the task that you need, go ahead and jump into the marketplace. Because in the marketplace, our partners have created over 500 build and release tasks. If you find what you need, download it and just start using it. If you can't find what you need out of the box or in the marketplace, what do you do then? You can build your own custom tasks. VSTS custom tasks, they're nothing more than PowerShell or Node.js. So what that translates into, anything that you can do from the command line, you can easily get VSTS to do. And what that translates into is this build and release system, you can make it do whatever you want very, very easily. So people always ask me, well, how do I start building a custom task? Every single one of Microsoft's tasks that comes out of the box with VSTS is open sourced. It's on GitHub. The fastest way to figure out how to build a custom task is to grab one of ours, download it, look at what we're doing, copy it. Hooray for that, you're done. Right? All right. So I'm assuming my build is done, because what could possibly go wrong? So we'll jump in there, and we'll see that the build is actually completed. We can see all the code changes that I made. We can see the work item that's linked to it. And these are deep links. I can click on it and actually go to it. We can see all the tests that were run, my code coverage, and it will show that it actually went through my release pipeline. In that time when I was going blah, 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 blah the entire time, it actually deployed my code out into Azure already. So we can go ahead and look at our release pipeline. So in this release pipeline, let's go ahead and see what it's actually doing. We create this pipeline for you, and it's a very simple pipeline. It's basically just, here's that environment that we deployed for you up in Azure. So it's just one. But if we wanted to make it more complicated, we can easily clone it. And maybe this can be my QA environment. I can clone it again, and this can be my production environment. And I can do something like that. If I wanted to as well, I can dive into each one of these environments that I'm deploying to. And this is just like the build system. It's a task runner. It does one task after another after another. Because we're Microsoft, deploying anything into Azure is ridiculously simple, right? We have pre-built tasks. So to deploy that web app into Azure App Service is one simple task. But if I wanted to customize this or configure this to do whatever it is that I needed to do, just like the build, you just add or remove tasks that you need. And out of the box, once again, you have hundreds upon hundreds upon hundreds upon hundreds of tasks to choose from. And once again, they're not just into Azure. You can deploy anything you want, anywhere you want. Into the cloud, behind your firewall, it doesn't matter, right? You can deploy anything, anywhere, however you want. So once again, you can look in the marketplace to find tasks that you need to do if you can't find it out of the box. And if that doesn't exist, you write your own tasks. One of my favorite stories is I was at a customer's, and they were using this, and they were like, OK, we have a load balancer on-prem. Behind it, we have 50 servers. We want to deploy our code on there, but we want to guarantee no downtime. So what we want to be able to happen is we want to pull a web server off the balancer, stick the code on there, pull another one off, keep on doing that, and then cycle them back on, so that way we can guarantee no downtime. Can you do that? And I'm like, OK, what's your load balancer? And they told me, I can't remember what it was, but I searched in the marketplace, couldn't find it, and I was like, OK, how do you guys do that right now? And they're like, oh, we have an exe that we run. We pass in these parameters, and we pass in the IP address of the machine. It pulls it off. We copy the code on there. Then we can run this exe again, and it will pass in these other parameters, and then it will hook the machine back to the load balancer. And I was like, oh, perfect, because I can write a PowerShell that does that really easily, right? So within 15 minutes, I created a task that uses that exe to pull the machine off, put the code on, and stick it back onto the load balancer. I uploaded the task, which was a PowerShell task, along with the exe. I bundled it together, loaded it up into VSTS, and hooray for that. They now have a task that can deploy code and guarantee zero downtime for their weirdly specific load balancer, right? Super easy to do, super easy to configure. So now, we probably have deployed our code all the way into our environment. Let me go ahead and jump in there. If we refresh this, eventually it will come back, and it should show our ASP.NET application. Right? So while that's spinning away, because it's the first time it has to compile everything and do all that nonsense, what I want to tell you guys is this DevOps revolution thing, it's not just here. We're deep, deep, deep in it. We all have to adopt a DevOps mindset. If we don't, everybody's going to be facing the exact same problem Microsoft was facing a couple years ago, about 7 years ago, which is our competitors already did, or they were going to. And if we didn't change and adopt this DevOps mindset, where we're continually delivering value to our end users, we would have become obsolete, right? Our competitors would out-innovate us, and we would become obsolete really, really quickly. And so that's the thing that I'm going to throw out to you guys as well. If you don't adopt this DevOps mindset, your competitors have or they will. And once they do, they absolutely will out-innovate you really quickly. And when that happens, we become obsolete. So in this DevOps world that we live in, we need to adapt, or we become extinct. And it's that simple. So go and download our tools, and let us help you enable this DevOps process. All right, thank you guys.